Good day. We are Group 6 and for today we will talk about distillation column. We are going to divide this topic into sections. First, we are going to discuss what is distillation, the application of distillation, what is distillation column, the different types of distillation column internals, and the main components of distillation column. Based from our previous discussions, we already learned that distillation is a separation process used to separate the various components of a liquid solution depending on the distribution of these components between a vapor phase and a liquid phase. In this process, all components are present in both phases, and the vapor phase is created from the liquid phase by vaporization at the boiling point. Furthermore, this process requires that the composition of the vapor must be different from the composition of the liquid with which it is in equilibrium. And always note that the distillation process is a physical separation process, not a chemical reaction. And it may essentially result to a complete separation wherein nearly pure components are obtained, or maybe a partial separation wherein we increase the concentration of a certain component in the mixture.
Hello, my name is JERILLY and I will discuss sample application of distillation. One known application of distillation is the perfume making. Distillation is done to get perfume ingredients from their natural resources. And it can be done in three ways, which are mainly dry distillation, steam distillation, and hydrodiffusion. Another example is in the manufacturing of alcoholic beverages. To get high concentration of alcohol by volume, we have to actually physically separate alcohol from water using evaporation and condensation, which is distillation. Because alcohol has a lower boiling point than water, therefore it evaporates before water, traveling into a cooling tube and back into another vessel to condense. Distillation is required for producing certain alcoholic drinks because of course, it increased the overall alcohol content in alcoholic drinks. The concentration of alcohol is increased from its original fermented concentration. Distillation is also important in the petroleum industry. Crude oil is made up of a mixture of hydrocarbons, and with distillation process, it can separate this crude oil into broad categories of its component hydrocarbons, or also known as fractions. Crude oil is first heated and then put into a distillation. Different products boil off and are recovered at different temperatures. The products produced on this distillation are butane and other lighter products, gasoline, naphtha, kerosene, bitumen, and many others. Next is the liquefaction of gases. Distillation can also be applied in liquefaction of gases. Gases such as nitrogen, oxygen, and methane require the use of very low temperature to liquefy and store them at relatively low pressures. To achieve this, a whole range of cryogenic distillation is used.
Distillation column. Distillation column is known to be an essential item used in the distillation of liquid mixtures to separate the mixture into its component parts or fractions based on the differences in volatility. So now I will tackle the basic operation involved in the process. We have here the liquid mixture known as the feed, and it is introduced somewhere here in the middle known as the feed tray. Note that the distillation column is divided into two sections, the upper and the lower section. The upper is known as the enriching or rectification section, and the lower is known as the stripping section. When the liquid feed is already introduced here, it will flow down to the column and it will be collected here at the bottom of the reboiler. And the reboiler heat is being applied to generate vapor, and usually the source of heat is in the form of steam. The liquid we obtained here in the reboiler is known as the bottom product. And the generated vapor here in the reboiler will be introduced here at the bottom of the column. And will further move upward in the column. And as it exits the top of the unit, it is cooled by a condenser. The condensed liquid will be stored here in the reflux drum, and some of the liquid will be recycled back to the top of the column, and it is termed as the reflux. The condensed liquid that is removed here in the system is known as the distillate product.
Next, I will discuss the type of distillation column. Types of distillation column should perform based on the type of separation needed and also in terms of complexity. This is a example of distillation column, a set of distillation column, and it's a sample of diagram. The first one is batch column. The feed that is being put into the column is in batch wise. Use of distillation in batches is called batch distillation. The column is charged with a batch and the distillation process is carried out. When the desired task is achieved, a next batch of feed is introduced. Next is the continuous column. The feed is being introduced in the system continuously, meaning there are no interruptions occur in the process unless there is a problem with the column or surrounding process. Continuous column can be further classified into two types, the trade column and the packed column. The trade column has trays, as you can see in this photo, and the packed column has packing beds, as you can see here. Trade column is a chemical equipment used to carry out unit operations where it's necessary to transfer mass between a liquid phase and a gas phase. In other words, is a particular gas-liquid contractor. Trade columns are used for making contact between a gas phase and a liquid phase to bring them as close as possible to the equilibrium state. Trade columns are widely used in various types of mass transfer operations, and all the simulation results which predict a certain number of theoretical stages. It can be converted into actual trays depending upon tray efficiency for a particular service. And here are the specifications of a trade column. Trade columns can handle wide range of gas and liquid flow rate. Trade efficiency can be predicted more accurately. Trade column operation is considerably smooth. Cooling arrangement can be provided in trade column. Trade column provides stage-wise contact. And last, when the liquid causes fouling or deposition of solids, even though the tray is blacked out, it is easier to clean it and manholes can be provided in the trade. Next is the packed column. The packed column use of distillation is a vertical cylindrical vessel containing an appropriate packing bed, supported and irrigated by the liquid flowing through a particular distributor. The bed height is determined by the packing mass transfer capacity, and constraints are governed by allowable pressure drop and overall column height. For standard mass transfer operations, packing can be considered as an alternative to conventional trays. However, packing is more sensitive to fouling problems than trays, and special attention for distributors at design step is required. Packing could be a good solution for revamping units where extra capacity, energy savings, or higher purity products are required. So here are the specifications of packed column. First, packed columns are more suitable for low capacity operations. Next, packed columns are particularly useful in the field of vacuum distillation. Here, column pressure drop is of paramount importance to minimize the pressure and temperature at the bottom of the column. Third, for separating heat-sensitive materials, packed columns are useful because the liquid hold-up is low. Fourth, when corrosion is a problem, packing may be the only answer. Fifth, pressure drop per unit length is less in packed column. Sixth, packed column provides continuous contact between the vapor and liquid phases. Next, packed columns are suitable for handling foaming system. Modern high-capacity peakings are available in practically any material. Last, total weight of packed column is less due to the use of low weight and high capacity. Next is the type of distillation column based on their function. It can be classified into absorption and stripper column or the fractionation column. Next is the type of distillation column based on their functions. It can be further classified into absorption and stripper column and fractionation column. Absorption and stripper column. Stripping column is a chemical equipment used for physical separation where one or more components are removed from a liquid stream by a vapor stream. Absorption column is a long vertical column used in industry for absorbing gases. The gas is introduced at the bottom of the column and the absorbing liquid, often water, passes in at the top and falls down against the cutter current of gas. The towers are also known as scrubbers. Petrochemical plants require the absorption of components from gas streams into lean oils or solvents. The resultant rich oil is then stripped or denuded or the absorbed material. So petrochemical plants use absorption and stripper column. Fractionation column. A fractionation column or fractional column is an essential item used in the distillation of liquid mixtures to separate the mixture into its component parts or fractions. It is based in the differences in the volatilities of the material. One noticeable industry that uses fractionation column is the petroleum industry. Fractional distillation is a process by which oil refineries separate crude oil into different, more useful hydrocarbon products based on the relative molecular weights in a distillation tower. The fractions at the top of the fractionation column have lower boiling points than the fractions at the bottom. All of the fractions are processed further in other refining units. So this is an example of fractionation column used by oil refineries where the crude oil is the feed and different products can be achieved. It can be petrol, naphtha, kerosene, diesel, lubricating oil, fuel oil, and bitumen. Next is the type of distillation column based on the nature of the feed. This can be classified into binary column and multi-component column. Binary column is when the feed contains only two components. And multi-component column is, of course, the feed contains more than two components.
Column internals. Column internals are usually installed in a distillation column to provide better mass and heat transfer between the liquid and vapor phases in the column. Column internals are usually trays, packing, distributors, redistributors, baffles, and etc., and they promote an intimate contact between the phases. The type of column internal used will determine the height and diameter of the column for specified duty because different designs have various capacities and efficiencies. For this presentation, I will just talk about the different types of trays and packing. First, we have here a bubble cap tray. A bubble cap tray has a riser or chimney fitted over a hole and a cap that covers the riser. So the cap is mounted so that there is a space between the riser and the cap and to allow the passage of vapor. Next, we have here a sieve tray. So usually sieve trays are metal plates with holes in them and vapor passes straight upward through the holes on the liquid on the plate, and the arrangement, number, and size of the holes are just design parameters. Next, we have here a valve tray, and in valve trays, it is usually covered by liftable cap. And as the vapor flows, it will lift the cap, thus self-creating a flow area for the passage of vapor. The lifting cap directs the vapor to the flow horizontally into the liquid, thus providing better mixing than is possible in sieve trays. Next is a type of packing. We have here random packing. In random packing, it is usually used in separation columns like distillation columns, and random distribution of small packing materials are used in order to increase the surface area for vapor and liquid contact while minimizing the complexity within the column. Random packing is usually designed to maximize the surface volume ratio and to minimize the pressure drop. Lastly, we have here structured packing. And structured packing is an organized packing, and it is usually used to channel liquid material into specific shapes. Materials used here are usually metals, plastics, porcelain, and we have to consider their internal structures must be arranged into different honeycomb shapes. Structured packings are designed in order to provide a large surface area for liquid to contact without causing resistance that impedes the liquid flow.
So what are the main components of distillation column? So the first one of the main components of a column is a column or tower. It is a vertical shell where the separation of liquid components is carried out. So this is the column or tower in the diagram. Next is the internals. It can be seen inside the column. It can be tray or packings, and it is used to enhance component separations. Next is the reboiler. It is used to provide the necessary vaporization for the distillation process. Next is the condenser. It is used to cool and condense the vapor, leaving the top of the column. Next is the reflux drum. It is used to hold the condensed vapor from the top of the column so that the liquid reflux can be recycled back to the column. This is the reflux drum, and this is the reflux or the recycled material. And the last one is the receiver. It is used to store the outputs from the top and the bottom of the column. And that's all. Thank you very much.